Okay, we are up to geometric sequences day 2. At the top of this page of notes, it says that there's a review section where you would complete each of the following. This, if we were in class traditionally, would be most likely a warm-up for you guys. So go ahead and try these at some point for practice, and then check with the filled-in version on the website. I won't necessarily take the time to go through these right now because I want to focus on new content only in this video. But if you have questions about what you're looking at on the website, either look back at the day 1 material or certainly send me an email and we could take care of that for you. So when we move on to something at the bottom half of that first page, which says geometric means, these are missing terms in a geometric sequence. We've done this very same process for arithmetic means in an arithmetic sequence. So I'll show you what it looks like for geometric means, and I think you'll be pretty good at it based on what we saw in the first day's lesson. So the main idea would be that we have 3, we're trying to find 3 geometric means, which means we need 3 blank spots to fill in between 3 and the last term that's given, which is 768. So in order to determine that, I want you to think that 3 is the first term. I'm going to call that A1. And if you look down at the end, this would be the 5th term, wouldn't it, right? Because this would be A2, A3, and A4. So how would I get to the 5th term based on the first term in a geometric sequence? Well, A5 would equal A1 times R to the 4th power, right? Again, this exponent is the difference in the terms that you're working with. The nice thing about these means questions is we'll know A1. Okay, so this will be, I think, a little bit comfortable for us here. So I'm going to plug in the terms that I know. This is 768. This is a 3, R to the 4th. And based on what we saw in similar questions yesterday, you're going to divide the 3 over to come up with R to the 4th is, let's see, 768 divided by 3 is 256. And then remember that from here you have to get rid of that 4th power, raise each side to the 1/4 power. And 256 to the 1/4 should be 4. Double check it though. Yeah, I get 4 as the ratio there. So you're not quite done as soon as you write down R equals 4. I'd like you to go back to the sequence and replace those blanks with the terms that we're missing there. So if you multiply by 4, 3 times 4 is 12. 12 times 4 is 48. I'm going to cheat real quick just to make sure. I think it's 192. Yeah, 192 is this term. And you should double check that multiplying that by 4 gets you to the last term of 768, which it does. So the 3 geometric means between 3 and 768 are 12, 48, and 192. Okay, let's try another quick one for practice. Find 2 geometric means between 3 and 375. So the number 2 geometric means is the number of blank spots that we will put in between 3 and 375. So it's 3 blank blank and then 375. So once you write it out this way, make sure you define those terms correctly. 3 is A1, 375 is A4, because this would be A2 and this would be A3. So the formula for this case would be A4 equals A1 times R cubed. All right, to get from the first term to the 4th term, we're multiplying by R 3 times. So 375 equals 3, R to the 3rd. Divide the 3 to the other side. This is going to say 125 equals R cubed. And if you raise both sides to that reciprocal 1/3 power, you're going to find in this case that R equals 5. If you know that the ratio is 5, go ahead and multiply by 5 here. So 3 times 5 would be 15. 15 times 5 should be 75. And double check it. 75 times 5 is in fact 375. So these would be the 2 geometric means between 3 and 375. I think you probably have caught on to the idea by now. We might benefit from trying one more question like it. Let's do number 4. So if you take a look at number 4, it says to find 4 geometric means between 1600 and -50. Okay, so the idea here would be 1600, 1, 2, 3, 4 spots, and then at the end you get a -50 out of that. So 1600 is your A1, and -50 is actually all the way down here at A6. Where students go wrong for a question like this is they usually, when they set this first equation up, that A6 equals A1R to the 5th, they just automatically put the bigger number on the left side, which I'll tell you in a lot of cases, it will be the bigger number. But if you look at what we've set up, the first number, A1, is 1600, but A6 is the -50. So you do have to be really cautious about how you set up your initial equation here. It should say that -50 equals 1600, R to the 5th, which means that you're going to have to divide both sides by 1600. Let's see what R to the 5th equals then. -50 divided by 1600 is this not so nice looking decimal. If you want to math frac that, you can. There's nothing saying you have to. I just kind of like the look of -1/32 better. And what do I have to do? I have to raise that to the 1/5 power. Okay. And you may be surprised that this will come out to be a nice number. Take that and raise it to the 1/5 power. You get -0.5 or -0.5 if you had left it as a decimal. So with an R value of -0.5, can we find those other missing terms? I sure hope so. Let's say half of 1600. You might not even need a calc for this. You're going to get -800 here, right, when you multiply by negative. But negative times -0.5 will be positive 400. So this is when we're going to see the signs alternate. Then you'll get -200 times -0.5 is positive 100 times -0.5 would in fact be -50. Okay, the work on this one probably is a little bit tougher than the first two I showed you, but go ahead and confirm that this makes sense to you as we've subbed in these values. Don't be afraid of those fractions and decimals. Okay, what we're going to see now is maybe some quick word problems that can be modeled using geometric sequence. You saw the same thing happen in the last unit with arithmetic sequences. There were some good word problems that modeled that type of pattern in numbers. So the first question says, in an auditorium, there's 12 seats in the first row, 18 in the second row, 27 in the third row. How many seats will there be in the 20th row? So to figure out the 20th row, A20, since I'm pretty confident this is geometric, it's going to be A1 times R to the 19th. So I definitely know that A1, the number of seats in row 1, is 12. So A20 would equal 12 times R to the 19th power. To figure out what R is, you can double check it by doing 18 divided by 12, which is 1.5. Maybe just quickly confirm that 27 over 18 is also 1.5. So we have that ratio correct there. So this is going to be a ratio of 1.5. Typing that into the calculator, 12 times 1.5, oops, not divided by, raised to the 19th power is 26,602. Round to the nearest whole number there. And maybe this is slightly unrealistic in terms of seats in an auditorium, because you had 12 seats in row 1. Go back just 19 more rows, and there's 26,000 seats. Oh my goodness. So if you had 26,000 friends, you could all sit together in row 20, I guess. But yeah, this probably would have been a better model for an arithmetic sequence. Regardless, though, that actually would be the correct answer in this scenario. Crazy auditorium. All right, our good friend Lauren's planting tulips in her garden, and the first year she had 5 blossoms. So if that's the first year, that's my A1. Each year after that, there were 3 times as many. 3 times as many. That's going to be a good keyword to know it's geometric. So the R value is 3. How many tulips blossomed 10 years later? So I want to know, what is A10? In a geometric sequence, A10 is A1 times R to the 9th. And then if I go ahead and plug in what I know that A1 is 5, the ratio is 3. I get the impression Lauren's going to have a lot of tulips. 5 times 3 to the 9th is, well, she started with 5, but now she has 98,415 tulips. That's a lot. Okay, I hope Lauren's a florist of some sort. Okay. I'm going to skip the next one, but it says at the start of an experiment, there were 10 insects. That's your A1. Hopefully you guys would remember that quadrupling means that the R value is 4. So you can try that on your own, check with the website. It's a really similar question to the last two that we've done. Okay, I am going to do Joe buying a car in number 4, just to make sure we understand what's going on with Joe's car purchase here. It should make sense to you that the value of a car would decrease as time goes on. We've talked about that in exponentials unit. And in fact, geometric sequences are examples of exponential functions. So in this case, we have the value of the car after the initial year and then 2 years later. Find the common ratio. The common ratio R, remember we're just going to take maybe the second term here and divide by the first term. You can also get this ratio by taking the third term and dividing it by the one that came before it, the second. It wouldn't matter. But if I divide that out, it seems like the common ratio is 0.75. So the way you would interpret that is that the car is worth 75% of what it was each year that follows. Okay, so you can use 3/4 if you want, or if you like the decimal 0.75, that's up to you. Find the car value after 8 years. So 8 years later, that would be A1 times R to the 7th. The initial value is 19,200. Okay, and if you like decimals, just use that 0.75 we had there. 19,200 times 0.75 to the 7th power is 2,562.89. I'll actually include the 0.89 here because we're talking about the value of a car. So I guess in theory, you can have some change that's associated with that. I'll go out to the 89 cents here since it's dealing with money. Okay, so just some quick applications of geometric sequences. And finally, the last part is this chart that's going to bring everything together. If you thought arithmetic was going away, think again here, people, because we've got a chart where we're going to determine, is it an arithmetic or geometric sequence? If it's arithmetic, we'll write the common difference. Geometric, we'll say the ratio. Write down what A1 is, and then find the next 3 terms in the list. And then we'll also figure out what A10 is. I may not do all of these, but we'll maybe at least take a look at the first 3 in the list. So we've got 4, 6, and 8. And if I'm looking at those, if I thought maybe it's geometric, I just want to make sure that 6 divided by 4 is the same thing as 8 divided by 6. And it turns out it's not. So if you're looking at that and you're saying, hey, what's the thing that I'm multiplying by? It's not a ratio of 1.5. That ratio didn't stay consistent. So it's actually going back to our roots, an arithmetic sequence with a common difference of 2, right? Aren't I just adding 2 to get from 4 to 6 and 6 to 8? A1 is 4. The next 3 terms after 8, just keep adding 2 to the 8, right? So that would be 10, 12, 14. And just as a reminder for an arithmetic sequence to find A10, it would be A1 plus 9D. The box that I have here is pretty tiny to include all the work in. So if you guys need, scrap paper, feel free to use it. So the value of A10 would be A1, which is 4. That's why I had you single it out earlier. Plus 9 times the difference. The difference here is 2. So 4 plus 9 times 2 is 22 for that 10th term. Make sure you're using the correct arithmetic formula as opposed to geometric. If I go over to 4, 8, 16, now it's geometric with an R value of 2, right? We're multiplying by 2 to get from one term to the next. A1 is 4. The next 3 terms after 16 are 32, 64, and 128 if you just keep multiplying by 2 to get the 10th term. In a geometric sequence, take A1 and multiply by R to the 9th. Okay, so let me just plug in what I know. A1 is 4 times the R value to the 9th power. 4 times 2 to the 9th is 2,048. And that was one of those fun apps back in the day, which I'm pretty sure is still around, 2048. Right? It actually has all to do with base 2 exponents there. So that's kind of a fun game if you guys want to try that out during this social distancing time. Last one, 4, 9, 16. If I'm looking at the pattern, am I adding the same amount? Well, 4 plus 5 is 9, but is 9 plus 5 16? Nope. Am I multiplying by the same amount? I don't really know. 9 divided by 4. 16 divided by 9, is that the same thing? So the answer is that it's neither of the two. And that's going to be your favorite type of example, because if it's neither, it doesn't have a D or R. I guess you could still say that A1 is 4. But I won't make you go ahead and find this next set of info for me, okay? So if it's neither, kind of cross off the rest of the chart and then try the other two. I'll give you just as a quick hint, this is geometric here, and the last one's arithmetic. Okay, check the website for the rest of the solutions there. And as always, please reach out if you have any questions, and enjoy the rest of the day. See you guys soon.